In this video, we are going to continue naming alkanes with other kinds of substituents. Next, we are going to be naming alkanes that contain two or more of the same substituents. The rules for naming alkanes are going to be very similar to the ones that we learned in the previous video. The first thing that we do is that we're going to write the alkane name for the longest chain of carbon atoms. Remember that that is called the parent chain. We are going to number the carbon atoms starting from the end that is nearest to a substituent. When we have two or more of the same substituent, a prefix needs to be added in order to illustrate that we have multiples of the substituent. When it comes to the locations of those substituents, remember that commas are utilized to separate the locations, and similar to what we learned before, those numbers for the locations and the words are going to be separated by a hyphen. Let's do the following examples. In the first molecule that we have here, our longest parent chain is going to have, as you can see here, 1, 2, 3, 4, 5 carbon atoms. So that means that our parent chain or the main chain is called pentane. Here we have two different substituents. We have a CH3 and we have another CH3. So because we have multiple of those substituents, methyl is the name of that substituent. Because we have two of them, we're going to use the prefix di in front of methyl, and then we're going to give the location of those substituents. Both of them are present on carbon 2, so we're going to do 2, 2, representing that both of those methyl groups are on carbon 2 in that main chain that is called pentane. Let's do the other example that we have on the slide. Here we have a skeletal structure. When it comes to this skeletal structure, we have 1, 2, 3, 4, 5, 6, 7, 8 carbons in length. We have to start numbering from the end that is nearest a substituent. In this molecule is going to be left to right. 1, 2, 3, 4, 5, 6, 7, 8. So our parent chain name is going to be octane. The substituents that we have here if we write in the carbon atoms, this is a CH2 followed by a CH3. That is called an ethyl group. Since we have two ethyls, we're going to write diethyl. And the position of those ethyl groups is on carbon number 4 and carbon number 5. So the name of this molecule is 4,5 diethyl octane. Let's do a couple of examples. From the practice problems that we have. I'm going to number these molecules 1, 2, 3, and 4. I'm specifically going to be working with 1 and 3. On molecule number 1, when I'm trying to find the parent chain, I have 1, 2, 3, 4. I am numbering right to left because that's the end that is nearest the substituents. My parent chain is called butane. My substituents are CH3s. This is called a methyl group. Since I have 2 of them, I'm going to put the prefix di. And both of them are on position 2. So this is 2,2-dimethyl butane. Let's move on to the example below. When I select my parent chain, I have 1, 2, 3, 4, 5, 6 carbons in length. That means that my parent chain is called hexane. Since I see that there's only a line connecting to my parent chain, that means that these are CH3 groups. CH3 as a substituent, that is called a methyl group. Since I have 4 of them, I'm going to put the prefix tetra. Next, I'm going to put the numbers for the different substituents that I have. I have 1 on carbon 2. I have 2 on carbon 3. That's why I put 3, 3. And the last one is on carbon 4. So the correct name for this molecule is 2, 3, 3, 4, tetramethylhexane. Make sure that you practice with the rest of the molecules that you have on the slide. And as you can see, we have examples 2 and 4 that you can work with. Now that we have explored naming alkanes with 1 substituent, naming alkanes with 2 or more substituents that are the same, let's now explore what happens when we have alkanes that have substituents that are different. When we have alkanes that have different substituents, the first 2 rules are going to be very similar to what we explored before. We're going to write the alkane name of the longest chain of carbon atoms, meaning the parent chain. Then we're going to number the carbon atoms starting from the end that is nearest to a substituent. We're going to give the location and the name of each substituent, but because they're going to be different, we're going to do it in alphabetical order. As we have seen before, the substituents are always placed as a prefix of the main chain, in other words, the parent chain. And remember that the numbers and letters are separated by a hyphen. Let's do the 2 examples that we have right here. First, let's find what is the longest parent chain that we have in this molecule. Overall, when we look at this molecule, we have 1, 2, 3, 4, 5, 6 carbon atoms. Since I need to start numbering from an end that is closest to a substituent for this molecule, I need to number from left to right. In this molecule, I have 3 different substituents. I have one on carbon 2. I have another substituent on carbon 3. I have another substituent on carbon 5. So on carbon 2, I have a fluoro group. On carbon 3, I have an ethyl group. On carbon 5, I have a methyl group. My parent chain, because there's 6 carbons, that's going to be hexane. When I write in my substituents, I need to put them in alphabetical order. So I start with 3-ethyl. The next substituent that comes in alphabetically is the 2-fluoro. Lastly, I have the 5-methyl. And then my parent, which is hexane. So that's the correct name for this alkane. Let's do the other problem that we have here as practice. Here we have a skeletal structure. When I look at this structure, I have to start finding my parent chain, starting from the end that is closest to a substituent. So I have 1, 2, 3, 4, 5, 6. Let me number the parent chain. In this parent chain, the name of it is going to be hexane. I have 2 substituents that are the same on position 2 and 5. That means that when I'm naming that, I can say 2,5 difluoro. On position 3, I have a different substituent. That substituent name is going to be 3-bromo. When it comes to placing these alphabetically, let's understand that if you have 2 of the same and you have another substituent that is different, the letters that you're going to take into consideration for alphabetization is going to be the name of the substituent. So what we are comparing is the B in bromo to the F in fluoro. The prefixes di, tri, tetra, for saying multiples of the substituent are not considered in alphabetization. So taking this into account, B in bromo is alphabetized first. So we say 3-bromo. Next, we have the 2,5 difluoro. And then our parent chain, which is hexane. When it comes to these practice problems, I'm going to number them 1, 2, 3, 4. Make sure that you practice finding the longest parent chain and how to name alkanes that have different substituents. Alkanes are not only straight chained. Alkanes can be cyclic. and they are known as cycloalkanes. These molecules have 2 fewer carbons compared to the open chain alkanes that we have explored already in this chapter. When it comes to the chemical formula for cycloalkanes, they are going to be given by the chemical formula CnH2n, in which the smallest number for N, it has to be 3. What that means is that your smallest cyclic alkane is going to be 3 carbon atoms. In the following slide, you can see that we have the cyclic alkanes for 3 carbons, 4 carbons, 5 carbons, 6 carbons. When it comes to this, understand that if you have a cyclic alkane, in order to distinguish them from the straight chain alkanes, the prefix cyclo is placed before the name of the alkane with the same number of carbon atoms. So if we have to name the cyclic alkanes, these will be the respective names. The one that has 3 carbons, this is going to be cyclopropane. The 4 carbon cyclic alkane, that would be cyclobutane. 5 carbon alkane, that is cyclic. This is cyclopentane. And lastly, a 6 carbon cyclic alkane. This is cyclohexane. Understand that when we are writing the condensed structures, which you can see in the first row, and the skeletal structure, you may not disconnect the ring system, because since they are cyclic, they're going to be connected in a cyclic structure. And as you can see in their skeletal formula, for these molecules, they're going to make different geometric shapes. Now let's learn how to name cyclic alkanes. In this class, we are just going to learn how to name alkanes with 1 substituent or alkanes that have 2 substituents. If your cyclic alkane has 1 substituent, all you have to do is place in front of the cyclic alkane name the name of the substituent, and then you're going to write the name of the cyclic alkane. So if we look at our first example, that cyclic alkane that looks like a pentagon is going to be cyclopentane. It has only 1 substituent, which is a Br. So we're going to put the name of that substituent, which is bromo. So the name of this molecule is bromocyclopentane. If your cyclic alkane has 2 substituents, then you're going to number the ring starting from the substituent that has lower alphabetical order. The numbering overall can be clockwise or counterclockwise once you have placed the value of 1. So when we look at this skeletal structure, we can determine that we have 2 substituents. The one on the right, that is an ethyl group. The one on the left, that is a methyl group. So when we're numbering the carbons, we're numbering the carbons within the ring system. So the carbon that is holding the ethyl is going to be number 1, because it comes alphabetically first. Then, in this case, in order to give the rest of the substituents the lowest number, we have to go counterclockwise. So we go, this is carbon 2, this is carbon 3. So when we name the following cyclic alkane, we go 1 ethyl, 2 methyl, cyclopropane, propane, because our cyclic system has 3 carbons in length. Let's do a few practice problems. From these structures, I'm going to specifically work with the middle one right here. Let me zoom in. First, I need to identify how many carbons are in my cyclic system. I have 1, 2, 3, 4, 5, 6, 7. If I have 7 carbons, that means that this is cyclohept for 7. And since this is an alkane, cycloheptane. When it comes to the substituent, there's a carbon right here, there's a carbon right here, there's a carbon right here. This is a CH2, CH2, CH3. So the name of that substituent is just propyl. Name of this molecule is propyl cycloheptane. Let's do one more practice problem. Here, I have a cyclic alkane with 2 substituents. This substituent is an ethyl group. This substituent is a methyl group. When we have 2 substituents in a cyclic alkane, the carbon that is holding the substituent that comes alphabetically first gets a number 1. So this is going to be number 1. Then we're going to number the rest of the substituents in the ring system such that they have the lowest number. So in this case, we have to go clockwise. So if this is carbon 1, this is 2, this is 3, 4, 5. So on carbon 1, I have an ethyl group. On carbon number 2, I have a methyl group. And since there's 5 carbons in the cyclic alkane, cyclopentane. Make sure that you practice with the other molecules that we have on this slide.